one, and I'm going to be writing more of these, but this is all I have so far. Breaking a CAPTCHA. I was very happy to find this because it's the first one that's directly related to security. So there's a few steps. First, you have to get some CAPTCHA images. Now, this guy took a WordPress CAPTCHA system that generated CAPTCHAs by just taking like several different fonts and twisting them and moving them around to make it a little hard to read. And he made like thousands of CAPTCHAs, and then he cut them apart in individual letters and made thousands of those images. And I found that you didn't need that many, so I trimmed away a lot of them, made it simpler, made this thing on my site called content2.zip. So these, by the way, if you put a bang in this Python environment, you can execute shell commands, which is pretty nice. I don't know if that's always true of Python environments, but this is how you can download something and unzip it. So I downloaded some things you need here, and here we're going to process these images a little bit. This is just going to display a couple of the images. So here's how I print the first image. This is an image of an R, and here's another image of an R. There's just a way to see what we're dealing with here. We're dealing with little letters that are one letter made a little bit hard to read, which is, of course, what CAPTCHAs are. CAPTCHAs are those things where they print something with the idea that only a human can read it. And with machine learning, that is increasingly not true. A machine can read it. All right. So let's put in that code and run it. And there it is, going to my website, downloading stuff. Here it's unzipping a bunch of these images. And here it is printing them out. Let me just shrink the thing a little. All right, so that's the first R, which is sort of tilted over. There's the next R that's sort of standing up more. And there's just a bunch of these different versions of R. So it's going to learn to tell these apart, all different letters and some of the numbers too. So that's what we've got, is a whole bunch of those images. Now, the next thing is you have to prepare the images. It's going to reduce them all to 20 by 20 grayscale, and it's going to change some, it's going to normalize them by making sure that the maximum is 0 to 1 instead of 0 to 255, which is just to meet the standard mathematical requirements of these training models. And then it's going to take the folder name, which tells it what the letter is supposed to be, and it's going to save it in a way so it knows this should be an R, this should be an S, this should be a T. So all this junk doesn't do any machine learning. This just manipulates the data to get it ready to feed into machine learning. And this, by the way, is true of every aspect of technology. 90% of your time is not the interesting part. It's the house cleaning to get ready for the interesting part. So this is what cleans up the images to put them in the right format. So I'll run that. This just downloaded the images and print a couple so we could see what they look like. This turns them into the right format for machine learning, and it doesn't put out any output at all. It's running, and now it's completed after 3 seconds. So it prepared them, but it didn't print out any output. So that's been done, but it's not very exciting. And this is the machine learning part, which is the main part I'm interested in for us. So this is going to define the model and then do a fit and test it. So let's take a look at it here where it's easier to see. All right, so it's again just a series of sequential layers. It has something called a convolutional layer, which I'm not really sure I understand. There are different kinds of layers, and I'm planning to add more projects where we practice with these different kinds of layers and learn what they do. But these first two layers do something simple like center the image in the frame. I'm not quite sure. A convolutional layer on another convolutional layer. This is the hidden layer with 500 nodes, and here's the output layer with 32 nodes because it has 26 letters and 10 digits, and I think they removed some that are really easy to confuse like O and 0 and L and 1. So they didn't quite have all possible 36 numbers. 32 is what they have. So there's only one hidden layer with 500 nodes. That's what's going to do it. And these are just more image processing layers. Then it's going to build the model, present a summary of it, and then fit the model. And if you include this validation stuff, it'll automatically run it on the validation set too and tell you how it's matching. So that's the code. Let's run that. Delete this old stuff, put in the new stuff. All right, and run it. So here's the model. You have 20 by 20 data coming in. You go through a couple of these conv layers. Then you go to the dense layer, 500, that does the work, and then the output layer, 32. So here it is. Notice now we have 667,000 parameters. Parameters are what matters. And by the way, GPT-4 is, I think, up to 50 or 100 billion parameters to do the language processing. So you see what we're doing here is a much simpler case, but the same logic. So now it's running these things, and when it runs them, each time it's going to print out these accuracy we need, which is the accuracy is the chance of getting it right. And 95 is this percentage. So it got up to 95% by the 7th epoch. 95% is correct. And the validation is 79%. So this is on the training data. We're getting it 95% right. On the validation data, we're only getting it 79% right, which is, as I say, that's not too surprising. So it's not a perfect match. And but anyway, it's getting some degree of success here. And that is breaking a CAPTCHA. And so if you get that up to, like 95 or something, then you'll be pretty good probably solving a 4-letter CAPTCHA automatically without being a human. And so I found a way to print out something so we can have a flag here to show you got there. And that's as far as I got writing these, but I'm planning to write a lot more because we all need to know how this works. This is going to be in everything very soon, and everyone's going to want you to put on your resume that you know how to do machine learning. Even a little bit will make you a lot stronger. So that. Yeah, Chat. 130 billion, right?
100 trillion.
100 trillion parameters. Oh, okay. Thank you. It's getting bigger. Okay. Yep. So here, this one here was about 200 or 300,000. 100 trillion parameters is ChatGPT-4. And that's where they say it's costing like 30 times more to use these AI than it does to do a normal Google search. So how you put ads in it and how you pay for it is coming. But right now, nobody cares. Right now, they're pouring tons of money into learning how to do this and building it into everything because now it's going to be incredibly powerful. Right now, it can find mistakes in code. It can fix your grammar. It can write business letters. It can summarize a video. It can do a lot. And it's all in the early stages of development. So